Section 4.1, Translating Expressions. 2 vocabulary words that you will be expected to know are variable and algebraic expression. Go ahead and copy down these vocabulary terms and the definition with the examples on your notes packet. The first one is variable. A variable is any letter or symbol that represents a number. And in math moving forward, in algebra, it is almost always going to be a letter. Some examples of those, or the most common variables used, are n, which is short for number. Then you also use a lot of x and y, especially when you start graphing equations, z, a, b, and c. Those are also very common variables used. The second vocabulary term is algebraic expression. Algebraic comes from the word algebra, and algebra includes variables. So an algebraic expression is a mathematical phrase with at least one variable. So you will be writing expressions or math phrases with a variable. And here are some examples. The first one is 6a. And what that means is 6 times a number a that we just don't know yet. 7p plus 1. That means you take a number that you don't know, you multiply it by 7, and then you add 1 to that. And your final example would be adding a plus b, and those are both numbers that you don't know. Evaluating expressions. You will be asked to evaluate expressions, and they will give you values for each variable. So all you have to do is plug in those numbers into your expression. Plug in is a very common or typical phrase that you're going to hear over and over and over as you work through algebra courses in the future. So the first one, 7a. First ask yourself, well, what does 7 next to the letter a mean? Well, you already know that that represents multiplication. So what that means is 7 times the number a. Well, if you look up here, you'll see that a is equal to 4. So if a is equal to 4, just plug that in. So what that means is 7 times 4. You just plug it in. So 7a or 7 times 4, then you can solve it. That is equal to 28. The second one is 2b minus a. Again, looking at the expression, you don't know what that would be unless if you know what b is equal to and a is equal to. And they give you that. They tell you that b is equal to 6 and a is equal to 4. So instead of b and a, plug in those numbers. So that means that 2 times b, which is 6, minus a, which is 4. Now you just follow your order of operations. You always do multiplication before you subtract. So you would do 2 times 6 first, which is 12, and then subtract your 4, and you get an answer of 8. And on the third one, it means 1.5 or 1.5 times the quantity b plus c. We'll plug in your numbers. You know that b is equal to 6, and you know that c is equal to -2. And a number next to parentheses means multiplying. Well, you still follow order of operations. You have parentheses here, so you have to do your parentheses first. 6 plus -2, following your integer rules, would be a positive 4. And again, a number next to parentheses means multiplying. So then you would do 1.5 times 4, which is 6. So to evaluate expressions, plug in the numbers that they give you and solve it using order of operations. The next part of this section is writing expressions. This is going to take verbal expressions or math phrases written in the long form using words, and then we can use a shortcut and write them using math symbols. So for example, the sum means that I'm adding two things. So what I'm adding two things, and the two things that I'm adding are 2 and 3. Just put them in the order that they are given. So that is a numerical expression. There's no variables. You're adding two numbers, 2 plus 3. The second example, the difference of a number and 10. Well, you have to ask yourself what operation is represented by difference, and we know that that's subtraction. And then what are the two things that you are subtracting? You always put it in order. A number. If you don't know what the number is, in math we use a variable, and you can use any variable you want. We'll talk about some that aren't wise choices to use for a letter, but n is very common. So let's just use n, the difference of a number and 10. So you're subtracting something you don't know, n, and 10. So n minus 10. The next example is the temperature increased by 5 degrees. We don't know what the temperature is, but we know that it's increased by 5. It goes up by 5. So in math, when we don't know something, we use a variable. And it makes sense if we're talking about temperature to use a variable that represents that. So we are going to use T. And no matter what our temperature was or is, it's increased by 5 degrees. And when something is increased, you add 5 to it. So whatever your temperature is, you add 5. And there's your expression, T plus 5. The next one is 5 cats fewer than C cats. Whenever you are talking about something that is fewer than, you are subtracting. It's 5 fewer, so you are actually subtracting 5. Well, what are you subtracting 5 from? You're subtracting 5 from the number of cats, C cats. We don't know what that is, so it's perfectly fine just to leave that written as C minus 5. Whatever number the cats you have, you take away 5 because it's 5 fewer than that. The next one is product. Product means to multiply, so you are going to be multiplying two things. And again, it just makes sense to do it in order. You're multiplying 5 and n nickels. You don't know the other number of nickels, so you're multiplying 5 and n, and you're going to use n because it's representing nickels. And the best way to show multiplication with a number and a variable is just put the number in front, and we have a special name for that, coefficient, but you don't need to know that yet. And last but not least, a dinner bill split among 5 friends. When you are splitting something, you're dividing it evenly. So you are starting with the total bill, and since we're talking about a bill, I might want to use the variable b. And I'm splitting it or dividing it among 5 friends, so I'm taking the bill and I'm going to divide it by 5. And moving forward, you should become very comfortable with representing division as a fraction, because that is the most common form that you're going to see division. And finally, you need to be able to describe patterns. So take a look at the table on the left. You see numbers on the left compared with numbers on the right, and you want to look for a very consistent pattern. So if you look at the first one, it's 1, 8, 2, 9, 3, 10, 10, 17. You want to check and see what's happening in each of those. Well, if you look, 1 plus 7 is 8, 2 plus 7 is 9, 3 plus 7 is 10, 10 plus 7 is 17. So then write a rule for that. No matter what the number is on the left side, you're going to take whatever it is, which we're going to use a variable n, and we're going to add 7 to it. And so that is your rule, n plus 7. On the right table, we go from 1 to 40, 2 to 80, 5 to 200, and then it wants us to fill in 10 and n. Well, if you look, if you multiply all of these by 40, you get the number on the right side. So it looks like whatever is on the left, you multiply by 40, and that gives you the number on the right. So for the missing one for 10 would be 400. And then you write your rule. It doesn't matter what n is, you take it times 40. And remember, whenever you multiply a number and a variable, you always put the number before the variable. That's it. Good luck.